were these your four homework problems right here? Is that correct?
Yes.
Graph 3x minus 5, quantity 3x minus 5 squared, 3 times the quantity x minus 5 squared, and 3x squared minus 14x minus 5. Yeah, graph them. Okay, actually, I think graph paper hurts Isaac. I think sketching them on just a coordinate plane is easier than trying to use graph paper because, yeah. Like, what's the y-intercept for this one? 75. You really want to use graph paper to go to 75? I don't. Yeah, right. I don't. Yeah, right. That's ridiculous. That'd be over 2. I think that'd probably be close to 3 pages. I think there's about 22. There's between 22 and 25 lines on a piece of graph paper. So yeah, that's ridiculous. Okay, so let's do number 1 very quickly. Oh, we don't even need to do this. Y equals 3x minus 5. I was very happy to see that it looked like everybody had this one right. So if that's negative 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, up 3, 1, 2, 3, and over 1. Good to go? Whoa, that got kind of like so schweckler right there, but anyway. I was happy to see nobody that did their homework got this one wrong, but I was sad to see that some people graphed number 2 and it looked just like that. Number 2 said, I would take notes on number 2 because I saw some crazy work on number 2. Even people that got it right did some nonsense. Okay, so for number 2, is number 2 in vertex form?
Yeah.
Definitely not. Good. Why? It is no. It's not because it's no plus 0. That's okay. That's not the problem. Why is it not in vertex form?
Because there's the 3.
The 3 is in front of the x. That's not A. This is not vertex form. Not vertex form. The vertex is not 5. The vertex is actually 5/3. The vertex is 1 2/3. It's 5/3. Dang, not vertex form. Not vertex form. Do you see? So I would write down, if I were taking notes right here, I'd write down, whoa, aguas, not vertex form, comma, cabron, or cabrona, whatever you like. Yes?
Oh, it's not in vertex form because the x isn't by itself?
Right, because if, like, there could be a number here, outside, but not a coefficient of x. It's not 1 right here. It'd have to be, yeah. So like the next problem is vertex form. Next problem is 3 parentheses x minus 5 squared. This one's not vertex form. Adiam, you got to do way better on your homework. You got to take it personal. Remember how George was proud that he did his quiz on Friday? He turned it in. He's like, grade it now. You got to have that kind of pride on your homework every day. George, you need to do your homework. Killing me. I know, right, Danny? Tell him. Smack him upside the head. Don't you want to have hundreds? Like, wait. Our current streak of hundreds is 2 in a row from Gabe. Don't you want to have the streak of hundreds? I would. A streak of continuous hundreds in a row. I know Diego wants a streak of hundreds. He's mad he doesn't have one right now. And that's good. I'm glad you're mad about it. Okay. Thank you. Stay with me. For this one, if I was graphing it, the thing I would do first is I'd find the y-intercept. The y-intercept is 25. Is that correct?
Yeah.
Plug a 0 in for x. So let's say that's 25. Are we good? Next thing I would do would be find the x-intercepts. A lot of people squared this, and that was sad because to find the x-intercepts, you just set it equal to 0, and you solve it. You can do square root. 3x minus 5 equals 0, so x is equal to 5/3. There's only one x-intercept. Yes? Even if you multiplied that out, it's factorable. Even if you multiplied it out, 3x squared, what is it, plus 30x? Oh yeah, minus 30x plus 25. That's factorable. You know what it's factorable to? 3x minus 5 squared.
Oh.
Oh, you guys are crazy. You're so worried about like how you do stuff, you forget what it means. Factoring is the opposite of distributing. If you got this by distributing something, it's factorable. I'm not making fun of anybody because I know there was probably, I don't know, 9/10 of the class did that, the quadratic formula. But do you see why it's really silly? Because factoring is the opposite of distributing. You got this by distributing. Oh boy. Okay, so I would do this. If you did the quadratic formula correctly, you get 1.6 repeating, which is the same thing. So the x-intercept, if that's 1 and that's 2, it's somewhere in there, correct? Turns out that's also the vertex. So do the line of symmetry. The reason I know it's the vertex is, well, okay. Here's how you would know it's the vertex. You square it, right? You get 30 divided by 6. Isn't that equal to 5? Like negative b over 2a. Do you follow me? Isn't that 5? You already know what happens when x equals 5. Like you can just plug it in, right? Plug it in right here. No? Wait, what? What? You guys are looking at me weird. What's going on? You got a booger? No? What's going on? Everybody's looking at me weird.
We want to see you smile.
I know it's a beautiful smile. I know it's a beautiful smile. Wait, what's going on? There's something wrong right here. What did I do wrong? Negative b over 2a is 5. What did I do wrong?
The vertex, not the vortex.
Not the vortex. The vortex is when you flush the toilet and it goes clockwise. That's a vortex. A vortex is a tornado. A vertex is different. What did I do wrong? What's going on?
I don't think you did anything wrong.
Yeah.
I think you squared it wrong. Because you started the experiment.
I think I squared it wrong too. I think this is 9.
It's like,
Yeah.
There's my mistake. There's my mistake.
Wait, what? It's 15.
I didn't hear you.
And it's 5/3.
There. Better.
You might want to fix the bottom so it looks cleaner for the video. Oh, okay. No, it's 8. Oh. Oh, wow.
Okay, look. All right. Anyway, 5/3. And you plug in, you already know what happens when x equals 5/3. That's the y, that's the x-intercept. Plug in 5/3, you get 0. So, anyway, point of reflection over here, right? Maybe right there. Yes, ma'am. It just barely touches. The vertex is where it turns around, so it just touches it and turns around. So there is one x-intercept. That's it. It's right here.
So then if it's an x-intercept, that doesn't have to go through?
It just touches it.
So if you draw it going through, you're wrong?
Yeah, because if it goes through here, then you have to go back through, and you'd have 2 x-intercepts. Do you know what I mean?
Not really. Yes.
So on the test, you just want us to like barely
Yeah.
Yes, yes. There's apps. It looks like math.
Uh-oh.
do it.
Is it minus 5?
Yeah.
Okay, watch.
It's so small.
How far?
Okay, check this out. You see the number? Do you see the y-intercept? Or you see the y-coordinate?
Oh my god.
You see the y-coordinate? Weird, right? It just barely touches it, that's it. It touches 0 at exactly one spot. It touches the x-intercept at exactly one spot, not 2. If it went through, it would have to go back, and it'd have 2 intercepts. I'm glad you guys asked that. So maybe that would be something you should write down right here, is that it just barely touches it just once. It does not go through it, it just touches it. Just touches it, doesn't go through. Yes, Michelle.
But it's just only for like that example, right? For the rest of them, it does go through.
If there's 2 x-intercepts and it... Wait, no, vertex, it just touches the vertex. It doesn't go past it.
So I've been doing this for well, no, I thought you just said that even when there's like there's multiple, right?
It just like, okay, if there's more than one x-intercept, it goes all the way through it. But if there's only one x-intercept, it barely... She was talking about the vertex. All right, boys and girls.
So for the vertex, if there's more than one intercept that it just barely touches still. It's just
It always just barely touches the vertex. Diego, you ready? Thank you. Is this one in vertex form?
yes.
Yes. What's the y-intercept? 75, because you put a 0 for x, 5 squared is 25 times 3. Right, Marcella? 75? Okay. What is the vertex?
Five.
5, 0. Correct? Do you need anything else? If you solved this, if you set it equal to 0, and you solved it, I would not square it and distribute. Don't do that. Use inverse operations when it's like this. In fact, we spent a lot of time completing the square, so you'd be smart and do that. Yeah. So take square root, x equals 5. X-intercept, vertex, same. So, yeah.
Wait, so on a homework we could just do it like that? Just like 75 times? No, like...
Yeah.
Really?
Yeah.
I wish I knew that.
Yeah.
I've told you guys a million times, there's only like 3 people not doing it that way anymore. I don't know.
I used to, and then I
Okay. Next one. Last one. The last one is y equals 3x squared minus 14x minus 5. Please let it be factorable. I don't want to use a quadratic form. Is it factorable?
Yes.
Is it factorable? Is it
Oh yeah, it
factorable?
is.
You want to see a trick? You want to see a trick? You want to see a trick? You want to see a trick?
Yes.
Correct? See where I got 15? Those are the only numbers that multiply to 15. Is this the same as this? Factor by grouping. Yes.
In your graph where there's, your table where there's just like the line straight down,
Yeah.
what does that mean? Like, what is that symbol? It's just a line.
Oh, that was
Like a minus sign?
yeah.
Okay.
I'm great. Caca for cuckoo puss. All right. So, Leslie, I don't teach this way because it's a trick. I like guess and check better. Guess and check is easier. It's faster. The bigger the numbers get, the faster guess and check is compared to this. People like this though because it's got steps. Steps aren't math.
What?
Steps are not math. Oh, you're asking AC. I would ask him what too because he talks so quiet. All right. So anyway, this one is factorable, right? So what are the x-intercepts? 5. Good. What's the y-intercept? -5, right? And the vertex? 7 thirds, comma, and then you plug it in, right? Which is like 21 and a third.
Yeah.
And so, right? -2 and 1/3. No, +2 and 1/3. Okay, so your graph, let's see here. -1/3 and 5. Good. -5. Then, like way down here. That's it. That was easy.